Say these are your 5 friends, and the 5 friends are vastly different in their physical characteristic. Say, for example, one that she has very long arms. So she's dominated by this DNA. This person has very short arms. So therefore, she's dominated by this type of DNA. This gentleman, he is very tall. So dominated by this DNA. And so on and so forth, depending on how they look, really is represented because of the DNA that they express. How does this relate to chemistry? Well, in chemistry, the molecules, they don't have arms, or they don't have legs, or they don't have eye color and things like physical characteristics that we normally possess as a human being, but they do have their own physical characteristics. Say for this ethanol and dimethyl ether, though they might have carbon, hydrogen, oxygen, they're very different in their own physical characteristic, also known as physical property. So physical properties are characteristics that describes a matter. And here are some properties that I like to cover. The boiling point, or also a condensation point. That's the point at which there is a change from liquid to gas for boiling, or gas to liquid. Then we have our melting point, where it goes from solid to liquid, or the freezing point going from liquid to solid. Surface tension, vapor pressure, size, density, mass, and volume. These are all different types of physical properties. Now remember, I have said that physical property for a human, for a person, is dominated by is dominated by DNA. Well, these top ones right here, boiling point, melting point, surface tension, and vapor pressure, these are dominated by intermolecular forces. Let's review the 3 intermolecular forces quickly before I talk about each of these physical properties that I have highlighted over here in red. So the very first one is hydrogen bonding. Then we have our dipole, and then London dispersion forces. Hydrogen bonding is known to have a very strong intermolecular forces between the 2 molecules. Not within the molecule, that would be a covalent bond. But between, right here, the hydrogen bond is known to be the strongest. Then we have intermediate, which would be a dipole-dipole interaction. And lastly, a London dispersion forces, the weakest one. And that's between, usually it could happen in all types of polar and non-polar molecules. And these are the weakest. Now, how does these intermolecular force relate to the physical property I have mentioned before? So our very first one is the boiling point, or the condensation point. The boiling point and condensation point, please, are 2 different phase changes. Boiling point is gas going from liquid to gas, and condensation is going from gas to liquid. Whether something is boiling or whether something is being cooled so that it becomes a liquid, the temperature is going to be the same. So if it's 100 degrees, if something boils, what's going to be the same 100 degrees when it goes back into the condensation point? How is that related, again, to hydrogen bonding, dipole, and London dispersion forces? Well, a chemical compound with hydrogen bonding will have the highest boiling point, meaning it will boil at a higher temperature and also will condensate at a higher temperature. If some molecule has a dipole interaction, then it will have an intermediate and condensation, intermediate boiling point and condensation point. Lastly, if it has just London dispersion forces, these have very low boiling point and very low condensation point. We still haven't we know the relationship. Okay, hydrogen bonding is going to have high boiling points, these high points, dipole, medium, and then London dispersion, low. But we still haven't described explanation of why this happens. And that's what I'll cover next. So why is that so? I have 3 different cups, okay? And inside the cup are 3 different molecules. I have water here, HCl, and then I have Cl2. So this one participates in hydrogen bonding, this one in dipole-dipole, and this one in London dispersion forces. And I put it under a heat. And the heat source will give rise from liquid to gas. So it went from liquid to gas. Okay. So what does that mean? That means that this hydrogen bond over here, let me zoom in real quick. That means that hydrogen bonding has been broken off. Well, it took quite a bit of temperature in order for the hydrogen bond to break to go into the gas phase. Hence why this will have a very high boiling point. What about the next one? The next one will do the same. Say I heat this up and it goes into a gas phase. I have to break that intermolecular force called the dipole-dipole in order for it to give rise to the gas form. So here's my gas on top and this is my liquid on the bottom. And it cut off this dipole-dipole interaction. And it didn't require as much heat, so less temperature in order for this to evaporate. How about something like Cl2? You gave it some heat, and this also went from liquid to gas form. But it didn't require much heat. It required very, very little heat in order for it to go from a liquid phase to a gas phase. Because of the difference in the strength of the intermolecular forces, because of that, there is different boiling point for the one with just hydrogen bonding and dipole-dipole and just with London dispersion forces. Let's do a learning check. Which of the following has the higher boiling point? It means that which of the following will have a higher boiling temperature? Now, here's a little hint. All hydrocarbons, meaning that they only have a hydrogen and carbon only, those guys are non-polar substances. So if that gives you a little hint, hopefully you can figure out what intermolecular forces it belongs to and also which one has a higher boiling point. Pause this video and come back. So coming back, benzene, this one is a hydrocarbon, which means that this is a non-polar substance. Something with a non-polar substance will only participate in London dispersion forces. I like to keep it short, LDF. Phenol, on the other hand, this has hydrogen and carbon, but it also has an oxygen. This OH here gives the whole phenol the ability to do hydrogen bonding. So this one would be hydrogen bonding, and also every molecule can participate in London dispersion forces. Therefore, phenol will have the higher boiling point since they have the greater amount of intermolecular force and it has that hydrogen bonding.